The State of Containers with Elton Stoneman.
The Azure DevOps Podcast is a show for developers and DevOps professionals shipping software using Microsoft technologies. Each show brings you hard-hitting interviews with industry experts, innovating better methods, and sharing success stories. Listen on to learn how to increase quality, ship quickly, and operate well. And now your host, Jeffrey Palermo.
Welcome to the show. I'm Jeffrey Palermo, your host. Make sure to check out www.azuredevops.show for past episodes and show notes. And make sure to check out all of those recordings from the virtual Microsoft build. There's just tons of content. And also, if you are running a user group and you're doing virtual presentations, I'm actually speaking at a lot of those, and I'd love to speak at your group event. And so get me on the calendar. I'm speaking to Azure Austin just coming up. If you're listening to this podcast, it probably happened shortly. And if you're tuning in here to the podcast for the first time, the Azure DevOps Podcast is for developers shipping software with Microsoft technologies. And my goal for all development teams is to be able to move fast, deliver quality, and run their systems with confidence. And that's what topics I try to get here on the show. And the sponsors are aligned with that mission as well. So today I have on the show Elton Stoneman, and he's a returning guest. He has spent most of his career as a consultant designing and building large enterprise applications. And then he discovered the container revolution. He joined Docker and worked with the team for 3 fast and furious years. And now he helps people break up those old enterprise apps and build new cloud native apps and run them all in Docker and Kubernetes. He speaks and runs workshops at conferences around the world, writes books and video courses, and helps organizations at every stage in their container journey. Elton is a 10-time Microsoft MVP and has also been recognized as a Docker captain. Elton, welcome back to the show, sir. How are you?
I'm good, thank you. Thank you for having me back. That's impressive, isn't it? That sounds good, all that stuff.
I know. Yeah. little did you know that you've done some things. That's awesome. Well, last time we spoke, and if those of you who haven't heard Elton's previous interview on the Azure DevOps Podcast, go back. It's, I believe, episode 67. You were at Docker at the time, and you've made a transition. Why don't you give us an update?
Yeah, sure. So I was with Docker for 3 years. I did a couple of different roles. I was a developer advocate, so I was doing a lot of kind of enablement of teams, talking to potential customers, and also speaking at conferences and running workshops and all that sort of stuff. And that was great. Did that for a year or so, and then moved over to our partnership team. So I was working with our kind of counterparts in Azure and AWS and GitHub, sharing information about what we were doing and what they were doing, and finding nice synergies and talking about how all that cool stuff was working out. And then I left Docker at the end of last year to go independent again. As while I was doing that Docker stuff, I was still writing my books and doing my Pluralsight courses, and I was just working too long. I enjoyed it all, but it was just I didn't have enough time to do anything else. And I thought actually I really liked the consultancy of being able to go in and short-term projects and help people with strategy and help people get up and running with changing the way they work. And I like doing the content, so I focused on that. Yeah, so I moved on, but I'm still a Docker captain, so I'm still heavily involved with that crowd. Awesome.
And like you mentioned, you actually have been able to crank out another book since that time. Is that right?
So last time we spoke, I was writing my Docker book, Learn Docker in a Month of Lunches. That's finished now. And I think it's literally going to be going to the printing presses in a week or two. So you can get the digital copy. It's fully done, and you'll be able to get the print copy soon. And I started what is effectively the sequel, Learn Kubernetes in a Month of Lunches. And I'm working on chapter 10. So I'm almost halfway through. I'm hoping to get that finished this summer.
Okay, so learn Docker in a month of lunches and learn Kubernetes in a month of lunches.
Yeah, awesome. They roll off the tongue, don't they?
Hey, well, there's no way that anybody will get confused with a different book, so that's good.
That's true.
Well, so you are one of the world's foremost experts, not just in containers, but specifically all the listeners here who are .NET developers and shipping software with Microsoft technologies, and of course we tons of Linux too here, but Windows containers, where there's tons of content out there about Docker containers, but there's no mention of Windows just because Linux came first. And now Windows is out there, and Microsoft is using they're dogfooding their own stuff, and the Windows container size has come down tremendously. It's I guess it's done. It's fully released, and people are actually using it, and it's working. And you're one of those few people that knows how that side works and how it needs to be used. So what's the state of the Windows container story, and what kind of workloads and scenarios are really easy now that didn't used to be?
Yeah, that's a great question. So I mean, the important thing is it's still different from Linux, because there are still kind of fundamental differences in how the Windows world works and how processes work in Windows. But from the outside, there's a layer of consistency, which means it's very, very similar. So if you're taking your existing application, so we're talking about kind of server-side apps. We're not talking about Windows GUI, because you can't really run those in containers. So we're talking about web servers and batch processes and even databases, message queues, that sort of stuff. You can take that and you can wrap it up to run it in a Docker container. And then you can spin up a Kubernetes cluster in Azure that has a bunch of Linux servers and a bunch of Windows servers, but it's one cluster. So it's one Kubernetes cluster. And where you deploy to Kubernetes is you send it a YAML file, a configuration file, which models your application. And it says, I've got this web server component which needs to run in this Docker container, and I've got this batch process that needs to run in this Docker container. And as part of that modeling, you can say, this should run on a Windows server and this should run on a Linux server. And then you pass that YAML file to your Kubernetes cluster, and it takes care of the rest. So, the job of Kubernetes is to run your containers for you. It connects them all. So, my Windows containers can reach my Linux containers, even though they're on separate servers, and, they're running separate operating systems and all that sort of stuff. It's all completely transparent. So we are at that stage now where it's all GA in Azure and in the other clouds too. The developer experience is still a little bit wonky. We can talk about that, but actually, beyond the developer experience, it gets much better all the rest of the way. So you can have a GitHub action that packages up your Windows application to run it in a container, and as a subsequent GitHub action that spins you up an AKS cluster and deploys your application. So that end to end is all there. It's and Windows is just another piece of the puzzle now.
Okay, one of the things that I've seen a lot of people be confused about is just the concept of, and these are people, obviously people who've published containers. They're past this, but there's still a lot of people ramping up on containers, and they're still having a tough time of answering the question, what is a container? And they say, oh, there's containers already in the container registry, but then there's all these different concepts. Like there's the container. Oh, but then what's a container image, and what's the specification of what the container should be? And if I want to base my container on a particular named image, and I need that based image. Oh, but I just need one custom font, because that's a canonical example. One custom font installed. What am I actually doing? Am I creating a new image? Am I creating just a Docker file? Can you piece apart and tell us what the unique concepts are, and specific to the Windows ecosystem, just to really demystify this so that people can start adopting this?
Yeah, definitely. I mean, that's a really good point. I think I want to do exactly what you said, but just before that, I think you raised a really important point, which is these technologies, Docker and especially Kubernetes, but Docker too. They're technologies where you can do a bit of Googling and you can get something from Stack Overflow, you can get something up and running, but you're going to hit the ground very fast with your face, because you really need to go back to the basic principles. Like, there are two technologies that really repay a proper investment in your time learning what those pieces are, learning how they fit together. Otherwise, you'll have your Docker file that you got from Google somewhere, and it's roughly similar to your own application. You copy it, you change a few things, and then exactly your point. Exactly, I want to add a different font from somewhere else. I don't know where to start because all I've done is copy and paste. So I would say this because I've been using these technologies for over 5 years now, but I think they work everywhere. Every platform is providing support for them, so I think they are a justified investment of your time. But I think you need to accept the fact that you're better off learning them from the ground up. So having said that, the main things you're talking about when you package up your container, the Docker file is effectively a script. It's effectively a deployment script that packages up one part of your application. So if you think of an application that has several components, each component will be a separate container because that gives you the freedom to update them independently and scale them independently and all that sort of stuff. So each component will have its own Docker file, and that Docker file will be something like start from the ASP.NET image that Microsoft provide. Now, an image is just a package of stuff. It's basically just a big zip file that contains a file system, a C drive. But on that C drive, there's a particular version of Windows Server. It might have IIS installed and .NET 4.8, and that's owned by Microsoft. So if my prerequisite to run my application is all that stuff, I don't need to have a document that says, right now, spin up a VM, install ASP.NET, configure IIS like this. It's all done for me. So I can just, in my Docker file, I'm saying I'm starting my configuration using this image that Microsoft provide. They keep it up to date when there's security patches or any other fixes. So, I can just inherit everything they've got. And then the rest of that Docker file, you're copying in your application binaries and anything that makes it your own application. So you start from a base and then you add your own stuff on top. You take that Docker file and you run a command like docker build, and that produces your own image. So my image is like a hierarchy. My image is based on Microsoft's ASP.NET image. As it happens, the ASP.NET image is based on top of the IIS image, and the IIS image is based on top of the Windows Server core image. So, they all kind of flow through like that. And then my image, when I build it, and to build it, you just need Docker installed. So Docker, if you're running in a development environment, Docker Desktop is free. You can use it with Windows and Linux. You just install it, and it just works. And you run these commands like docker build. That gives you an image, which is just this big zip file of a C drive in the Windows paradigm. And then you can share that on this thing called a registry. And registry is just a server, public or private, that understands about Docker images. So I can push my application to a registry, which might be Docker Hub, which is a public registry, or I might have my own private registry on Azure, Azure Container Registry. And then whoever I give access to can get that image. Now, when you've got that image, you run a container from that image, which is effectively an instance of your application. So if I've got an image that describes a web application, I can run that in a container on my machine, and the image has everything the application needs. So it's got all the prerequisites, the binaries, the configuration, everything I need to run that app. So wherever I do that Docker run command, it will download the image, and the application will work in exactly the same way everywhere. So they're the kind of main pieces. The Docker file produces an image, the image runs a container, and you share everything on a registry. So those are the kind of the individual building blocks.
Okay, so you can run multiple containers from the same image.
Yeah, exactly. So
kind of like you have multiple objects in runtime come from the same class file.
Exactly. Yeah. So if you're from a development background, you can very much think of it like that. Your image is a class, which also has that hierarchy element to it, and your containers are instances. So I can have multiple copies of the same container. That same container.
And a lot of people are used to deploying everybody has a web application. They're deploying their web application to an iss-vm, or deploying the web application to Azure App Service. Mm-hmm. Do you deploy your application to a Docker container, or do you create a new image that has the files of your application in it?
You package your application to an image. So your image is the static thing that you can share, but you deploy your application by running a container from that image on a machine that has Docker installed. So when you describe I deploy my application to an IIS server, well, in order to do that, I need that server to have IIS and to have .NET installed. When I'm running things in Docker, because the container image has the whole stack, all I need is Docker. So, when I'm running my stuff in Docker, I don't even need .NET installed on my server. I don't need Java to run Java apps. I don't need Node to run Node apps, because all that stuff comes with the image. So literally all I need is operating system, Docker, and everything else comes with the container images.
Okay. And I think DockerCon and Azure, they've had some recent announcements that probably going to affect the rest of this conversation, but also affect everybody's lives. What's new there?
Yeah, quite possibly. So, like you say, when we talk about deploying to a server, you've got a few different options there. But maybe I've got if it's a test server, I've maybe got a VM running in Azure. I've installed Docker on it. There are VM in the marketplace that have Docker already installed. And then when I'm using my Docker command line on my machine, I can point it to a remote Docker server. So I can say, I'm going to switch my context to my Azure test server. So when I do my Docker container run, it's the test server in Azure that's going to download the image and run the container. And that's fine, but then I've got a VM that I need to manage. And actually, people are starting to care less and less about the VMs and the underlying infrastructure. I just want something where I can run my containers. Mm-hmm. And Azure has this offering called Azure Container Instances, which does exactly that. You can use the AZ command line or PowerShell or the portal, and you go and say, I create my new container instances, run me my web application. Here's the name of the container image, and click go, and away it goes. And then, behind the scenes somewhere, there's a VM gets allocated to you, or you're sharing a VM that's already there, and it downloads the image from the registry and starts your application. And that's been around for a long time. It's very nice. But there's this big disconnect between when I'm a developer working with Docker, I'm using Docker run commands, or if I'm modeling my application, I'll use Docker Compose, which is yet another thing. And then when I want to run these things in ACI, which I can also do for production, if it's a small application that doesn't need the power and the complexity of Kubernetes, I can spin up a prod level supported managed service in ACI, but I'm modeling it in a different way. So dev and test locally, I'm using Docker and Docker Compose. And when I switch to production in Azure, I'm using AZ commands and PowerShell, or whatever works for me. Even ARM templates, if I'm brave. The new announcement from Docker and Microsoft, they've been working together to make ACI behave like it's a remote Docker server. So when I'm a developer with my Docker command, or if I'm running inside a CI process in a GitHub action or whatever, I can switch my context to say point to my ACI instance with whatever credentials I've got stored in secrets, however I'm doing that. And then when I do a Docker run or a Docker Compose up, it's the same tools, it's the same files, it's the same way of modeling my application that I use everywhere, but now it's spinning up in the cloud in Azure containers. So if I'm going from, I've got my Docker Compose file that describes a web application and a message queue and a batch processor. Well, now I no longer have to translate that to a bunch of AZ commands. I will literally be able to do Docker Compose up, and it will spin those things up in ACI. I don't worry about the VMs or the version of Docker or how these things connect together. It's all taken care of for me. Should point out that you can't do it yet. It was announced at DockerCon. There's a really cool demo. I think it's coming later this year.
That's going to be awesome. And I'm thinking about scenarios where, gosh, all of the slightly older applications, we might call them legacy applications, but they're really current applications where just because of a certain class of dependency, they're stuck on virtual machines in absence of moving to a container. They can't use the PaaS services in Azure because they don't have the right barcode font available, and you can't install them, or they read from a legacy access database as an upstream data source, and there's no access runtime or Office development. I mean, how many applications used parts of the Office development stack, or they generate PDF files, or just any number of dependencies that Azure doesn't bundle in the PaaS services. And just because you need that little library, you've got to use and manage a whole virtual machine. And this sounds like a pathway for that whole class of application that just need that one extra dependency, and then they could run in the app service umbrella.
Yeah, absolutely. So I mean, that whole thing, the the Docker file and all this stuff that you kind of have to learn. The payback for that is that you can run pretty much any application. As long as you can script the installation of whatever barcode font or horrendous 1990s PDF library. As long as you can script that, you can put it in a Docker file. And then you can package that whole thing up to run in a container. If your app will run on Windows Server 2019, then it will run in a Windows Server container. What we're describing that you can do with ACI, you can do it right now with Kubernetes. It's just a very complex system. So if you want the power of being able to run these things in a portable PaaS, which is kind of what Kubernetes is. You can kind of view it like that. So I go through all the investment of packaging my apps to run in Docker containers. I model them in the Kubernetes API and all these YAML files. Then I can run them in Azure or AWS or in my data center or whatever. But there's this steep learning curve. Even once you've got Docker down and you're happy with how containers work, there's yet another learning curve to learning Kubernetes. And if you can avoid that and you don't need all the power of Kubernetes, if you can do something simpler, then I think that's going to be big for a lot of people.
Well, let's dig into that. I'd like to. What's your sense of fast forward down the road, whether it's 5 years or some number of years, and you have this massive developer population out there. Mm-hmm. How many developers, either now or in the future, are really going to need to know Kubernetes? And how much is Kubernetes just kind of maybe it's running under the covers in Azure somewhere, and maybe there's like 2 or 3 settings that you have to choose what to make that. How many developers really need to invest the time to actually know Kubernetes?
Yeah, that's a great question, because the investment in time is potentially infinite, because so much is happening with Kubernetes all the time. I think there's a couple of things there. There's the platform itself, the infrastructure. Kubernetes integrates really nicely with kind of wherever it's running. So I can describe an application in a generic way, and when I deploy that to AKS running on Azure, it integrates with Azure files to give me storage. It integrates with when I publish a service and I tell Kubernetes it should be publicly available. It's going to get me a public IP address from Azure. It's going to link that to load balancers. It will send those into the VMs that are running my servers that are part of my cluster. So there's the kind of platform bit which no one cares about, and no one really wants to or should have to, because that's what you're paying for. That's the managed service. So I literally go on and I use my AZ command, and in a single command I spin up a Kubernetes cluster with a mixture of Windows and Linux nodes that can run thousands of containers and cost next to nothing comparably. And then there's my actually describing my application, which is the modeling part. And there's people are often asking me, like, who does that even sit with? Does that sit with developers, or does that sit with ops, or is that something that they work on together? And the only answer is it depends on your organization and who wants to learn what and that sort of stuff. And that's the complicated bit. So the API, the way that Kubernetes describes your application and how you tell it all the pieces fit together, that's the complicated bit. So yes, it's complicated running your own cluster, but you can give someone else to do that. But even if somebody else does all that stuff, it's still down to you to model your applications. And Kubernetes has all these different types of resources that fit different types of application. You can do like stateful applications where I could run at scale, but they start sequentially and they can all talk to each other and they can all find each other, all the way through to stateless applications where I just want to run 100 instances somewhere and they all start as fast as they can and all that sort of stuff. You can model all that stuff with storage, with surfacing configuration that lives inside the cluster, dealing with secrets for API keys and credentials, sending network traffic. So Kubernetes models the compute layer, the storage layer, and the networking layer. And you have to understand that if you want to use it. So there's a lot of interesting discussions about, will the platform die? And so I would just have this YAML file or this set of YAML files that I throw to something and it goes and creates everything. And it may not even be Kubernetes under the covers, but I'm using Kubernetes as a standard way to describe and model my application, which is very attractive, but it's still complex. And there's still a question of whether you kind of need to go to all that. Because at the moment, the way Kubernetes has evolved, like the API is inextricably linked with the platform because it models the capabilities of the platform. So, if you want to be able to describe things in a more abstract way, it's going to need another evolution of the API to say, I want to be able to have these sets of features without explicitly describing that it's a stateful set where things get created in sequence. I think there's another layer of abstraction. So a very extremely woolly answer. And the more explicit question of how much do developers need to know, I think it's really down to your appetite and where you think you want to invest your time. Because if you're an Azure person, like I guess we all are here, your time's full enough just keeping up with what's coming out of Azure.
Sure.
I've been an Azure MVP for years and years, and I know less and less of the platform because I'm having to specialize in the bits that I work with, and I have a smattering of understanding of the wider thing. Don't tell anyone that because I'm due for renewal, so I wouldn't like them to know that. But then then if you're always going to be working in Azure, then maybe you're going to spend your time looking at the power side of Azure, and you're going to kind of get completely down with that. But then if you can't really take that somewhere else if they're not using Azure or they're using Azure differently. So I think the great thing about Kubernetes and Docker, although I classify Docker differently because it's so much easier. You really can be up and running with Docker with a couple of weeks. You're not doing that with Kubernetes. Mm-hmm. So the investment in Kubernetes is that I can kind of take these skills anywhere. I worked on a project where I was taking an old Windows application. It was a Fortran application, and we wrapped it up to run it in Windows containers. We ran it in AKS up in Azure, and we did like a quick POC, and then we did another couple of weeks making it kind of production ready. And that the handover from me back to the client was really a README document that described all the different pieces of the architecture, which had links to all the Kubernetes YAML files and the Docker files, and that was it. Like if you understand Kubernetes, you can join that project straight away with no understanding of what the software does or how it's different from other applications. Because you understand the modeling language, you understand how it's being presented, and then you look at the Docker files and you see what's being packaged. So you can move freely between projects, between organizations. You can onboard people onto your team and get them running extremely quickly. So the payback of investing all that time is that you can kind of take that stuff anywhere. So yeah, it's a question of whether you think your next 5 years you want to be spent working on Kubernetes manifests, or whether you think your time is going to be better working in PaaS.
Well, contrast that to Azure Container Instance, and I think probably at some point, if it doesn't already, Kubernetes is going to be under the covers somewhere hidden, but that's another option, right? For running a container, and you can even scale out with multiple instances. So what's the thought process of, do I just have the Azure App Service kind of running my containers and put it there? Or what are there known limitations that people need to be aware of there?
Well, so what you can do right now actually with ACI is you can do more than just have, here's my container or here are several instances. When you spin up ACI, you have this notion of a container group, and I can have containers running from different images that are all part of the same kind of virtual network, so they can all see each other. So if I do have that application that's run across multiple components, I can still model that using ACI. But right now I'm using, AZ commands or whatever to start them up and configure them. The move that's coming later this year is I'll be able to do that modeling using Docker Compose, which is another way to model these kind of multi-container applications, but it's very much simpler. I mean, the learning curve for most people is I learn some Docker, and then I get a component packaged up, and then I learn Docker Compose, and then I learn how to do distributed applications in containers. Well, Azure Container Instance will be able to use that Docker Compose file, which is super simple. Like it's usually like a tenth the size. It's still YAML. It's still describing individual components and the parameters to run them, but it's about a tenth the size of a Kubernetes manifest or smaller. And it's because it's not so expressive. You can't do as much. You can't model the same level of detail. It doesn't have all the features of Kubernetes. I think what's going to be interesting is that the Compose manifest, the whole Compose API recently went open source. So there's a Docker. It was previously a Docker project. Now it's totally open source. So other people are being able to use the Compose specification to describe applications that run on something other than Docker Compose. So, you'll be able to use it to, AWS have this equivalent of ACI. So that, you could potentially use Compose to describe those things too. But it's not extensible. So there is no way at the moment for Docker Compose to say, here's my application. And when I run it on my machine with Docker Desktop and I do Docker Compose up, it does this. But when I write an ACI, then, I need to tell it to give me 2 gig of RAM for this component and 4 cores for that component. Mm-hmm. But part of what they're doing with opening up that spec is including things like that in a generic way. So you will be able to say, here's a block that only applies for ACI, which tells you I'm running on Linux, I want 2 gig of RAM, and I want 4 cores. And for this component, which is part of the same application, this runs on Windows and it needs 8 cores and 64 gig of RAM. You will be able to do that, and it's be interesting to see how kind of nicely that all fits together.
Okay, awesome. Well, as we kind of get to the tail end here, I can kind of hear the listeners saying, "Okay, I hear all this. Where's the quick start? That's not a quick start. Where's the real start? Not the one that's like, oh, here's the quick start, but don't do it this way. Here's the no, seriously, do it this way." And I mean, how many applications? I've said this so many times. How many applications out there fit the general shape of a web application, a relational database, and some type of offline job? Previously it would have been an IIS application, a Windows service, a SQL database, and maybe it's an Azure PaaS now, but it's the same deployed components. So even for that simple structure of an application, is there a just do it this way if that's the shape of your application in Docker in Azure?
If only you could, point something at your file system and it would build it all for you. I don't think so. I mean, so I think what the stage we're at the moment is there's this kind of, everyone got really interested in containers, and then there was this explosion in how you could run containers. So even now in Azure, there are 4 or 5 ways to run a Docker container, from running your own VM to running AKS to running ACI, Azure DevOps, bits of that stuff running containers, GitHub Actions, they are running containers. So you can make use of Docker in lots of different ways. What I think we're kind of hopefully coming to this convergence where it is, if you want all the hardcore tweaking that you can do with Kubernetes, then here's AKS, right? And you know what you're getting because it's just Kubernetes, but it integrates really nicely with all the other parts of Azure. And if you don't need that stuff, here's ACI. And you can model things in the Docker Compose format, which is nice and simple and hopefully will become more and more universal. So I think that's what the Docker team are kind of hoping, is that Compose becomes a generic format to describe an application that is, here's my web app, here's my offline app. There's enough detail there to be able to run it in different ways. And that would be good. In terms of, where do you start with that? Well, you need to get yourself some good books.
I wonder where we could get one.
So it's a good point. And it's one I've been, I was talking to went for DockerCon. The most recent DockerCon was a completely virtual event, but they wanted to try and keep some of the cultural stuff, because, a lot of the conferences are people you bump into in the corridors and you have conversations. So as well as the sessions that were being streamed, there was a kind of YouTube channel with some of the Docker captains and some Scott Hanselman dropped in, just chatting, for an hour segment. And I was talking to a couple of the guys who are writing books and producing courses about this sort of stuff. And it's great because we have different backgrounds and we all have different takes. But the thing that I try and do is exactly what you've said. Don't give people the 101 that you're never ever going to do in reality. It's really hard, particularly with Kubernetes, to separate the how you do it with the why you would do it this way and what it gives you. So what I try and do is all of my exercises and examples are as real life as possible. So I use multi-container applications. I've got several apps that I use, throughout different chapters that I keep referring back to. So hopefully people don't get bored. But yeah, I mean, if you go and look at some blogs and you follow through and you start learning about Kubernetes, the first 4 or 5 things they have you do don't even use YAML, and you're creating objects, and you never ever do that. So I think I do that in the very first exercise, and then I say we're never going to do that again. We're going to learn the YAML because that's what you have to do. So yeah, that resource that tells you how to get started. Actually, if you're from a .NET background, it's not specifically about Azure, but the workshop that I do at conferences, all the content for that is public. So you can go to http DAK4.net, DAK4.net, Docker and Kubernetes for .NET developers, and all the content is public. So it's just a bunch of slides. There's a GitHub repo. We take an old .NET framework application and gradually we put it in Docker, break it up into pieces, and then get it running in Kubernetes. So if you're interested in that kind of, here's an example that starts with a real-ish application and gets you towards a more modern architecture, I would hope that's a pretty good resource.
All right, we'll include that in the show notes. That's a good resource. All right.
Cool.
And we'll also include a link to your 2 books. Because I imagine that even though the second one's not quite done, it's probably online.
Yes, yeah, you can get the first, I think you can get the first 7 chapters now, and you'll be able to get the next few in the next couple of weeks. So they're published by Manning, and Manning have this great early access program. So as I'm writing the chapters, that you can get them, and then you get feedback. So the Docker book I wrote, tons of great feedback that made it better. And so, yeah, I'd love to get the feedback on the Kubernetes one too.
Awesome. All right, Elton. Well, thank you so much for coming back to the show. This is a lot of great update.
Cool. Yeah, thanks for having me. And if I can think of a third title for the trilogy, I'll let you know. I'll come back.
Fantastic. And until next time, keep shipping.
You've been listening to the Azure DevOps Podcast, a show for developers and DevOps professionals shipping software using Microsoft technologies. Go to www.azuredevops.show for show notes and other episodes. On behalf of your host, Jeffrey Palermo, and our sponsors, thanks for listening, and may God bless you.